In this section of notes, we're going to talk about simplifying radicals. In order to be able to simplify radicals, we have to know what a perfect square is. A perfect square is the product of one number times itself. You can take the square root evenly of all perfect squares. So ones that we're really familiar with are things like square root of 1, square root of 4, square root of 9, square root of 16. I have them listed here all the way through 144, which would be, if we take the square root of 144, we would get 12. However, these keep on going. 13 times 13 gives us 169, so the square root of 169 equals 13, and these continue on forever. These are the ones that we're mostly going to need to know for what we're doing in class. Make sure that you know the perfect squares well. So, to simplify a radical, what we're going to do is we're going to have a square root like square root of 50. We cannot take the square root of 50. We could, if we wanted, we could use our calculator and type in the square root of 50, and it will give us a decimal 7.07106. However, this is a rounded value. This is not the exact value. So sometimes in the upper level math, we have to simplify a radical so that we get smaller numbers to deal with, but we don't have a decimal. So for square root of 50, what I'm going to do when I'm simplifying radicals is I'm going to think to myself, what could I multiply together that would give me 50? I could use 5 times 10. If I did that, I would have the square root of 5 times 10. But if I use 5 and 10, that does not get me anywhere because I cannot take the square root of 5 and I cannot take the square root of 10. They are not perfect squares. So, rather, let's try to think of some perfect squares that we could use. And we see right here 25. So, I could write this as a square root of 25 times 2. And we can write these separately if we want. The square root of 25 times the square root of 2. That is a property of a radical. We can split them apart whenever they're multiplied like this. And we know that the square root of 25 is 5, so we would write this as 5 times the square root of 2. So square root of 50 equals 5 square root of 2. If you don't believe me, we can type it in. 5 times the square root of 2, and we'll also get that same decimal. So these two are equivalent. This is what we call the simplified radical. I know that you might could argue that actually seems less simple, but that's what they call it in upper level math classes. Let's look at number 2. We could here break up 120 to be 12 times 10, but 12 is not a perfect square and 10 is not a perfect square, so that does not help us any. So we're going to look at all these numbers and we're going to try to find a number that we could multiply with something else to get 120. I know that 4 here will go into 120, so I could write this as 4 times 30. 4 times 30 gives me 120. And it is useful because I know that the square root of 4 is 2. When I take the square root of 4, it becomes 2. It is on the outside of that square root. The 30 is going to stay on the inside of the square root. I cannot break 30 down any further, so I would stop right there. So square root of 120 would equal 2 times the square root. Here I have the square root of 192. 192 is a bigger number, and I do not know all of the factors of 192, so I'm going to use my calculator on this problem. So whenever I'm looking for a perfect square that I can use for this, I want to use the largest perfect square. So for example, if I use 4, that would work, 4 times 48, but 48 would break down over and over and over again, and I'd have a very long problem if I did that. So instead of starting from the bottom of the list, I'm going to start from the top. So if I try like 192 divided by, I know 100 won't go, so maybe 81, I get a number that is not a whole number, so I know that does not work. 192 divided by 64, that gives me 3. So the best thing I can do here is I can break this into 64 times 3. And whenever I do that, the square root of 64 is 8. It goes on the outside of the square root. And we cannot take the square root of 3, so it stays on the inside of the square root. For example 4, I have the square root of 80, just to give you a little bit of an example of how it would look if I chose the smallest perfect square. Let's break this into 4 times 20. Okay, so if I take the square root of 4 times 20, I get 2 times the square root of 20. However, 20 will also break down, so I would have 2 times the square root of 4 times 5. Then the square root of 4 is 2, so I'd have 2 times 2 square root of 5. And then 2 times 2 is 4, so I would get 4 square root of 5. Now, all of that could be avoided if I had chosen a bigger number. So, since 4 works, that makes me think maybe 16 could possibly work as well. And sure enough, it does. So, instead, what I could have done here is I could have said that the square root of 80 equals the square root of 16 times 5, and the square root of 16 is 4. The 5 has to stay underneath the square root because we cannot take the square root of 5 evenly. So you see that I get straight to the answer if I choose that highest perfect square. So whenever you can, try to use the highest number that you can possibly use there. If you're ever left with an 8 or with a 12, then that means you could break that down further. So always remember that. So for example 5, here's another example. I could use 4 times 12, but that is not going to give me my highest perfect square. So if I check some others, 48 divided by 16 is going to give me 3. So I could do 16 times 3. The square root of 16 is 4. That goes on the outside of the square root. The 3 stays on the inside. So the square root of 48 equals 4 times the square root of 3. Now, let's look at some examples that have variables. Okay, so whenever you have examples of variables, you are going to do these problems. The number part we do just like we did the last problem, but the variable is going to be a little bit different. To help students remember this, I normally do this. We know that we are going to break 60 down. If we look at our perfect squares, 60 divided by 4 is going to give us 15. So I'm going to break 60 down into 4 times 15. And then I'm going to write all of my x's out. Okay, so whenever I have 4 times 15, then I've got these 5 x's. This is not very mathematical here, but this is what I teach my students to help them remember what to do here. I teach them that the square root is like prison. So if you are in prison, then there are 2 ways that you can get out. You can either be perfect or you can have a partner. So whenever we have numbers like 4, that is a perfect square, so it can escape and it becomes a 2 because once you're on the outside, you're just not the same anymore. Square root of 4 is 2. That's like we've been doing so far. 15 is not perfect, so he is stuck in jail. He cannot get out. Whenever you're a variable, things are different. So to get out of prison, you have to have a partner in crime. So these 2 can be partners and these 2 can be partners. However, as they escape, one of them gets shot and only one of them makes it on the outside here. So what happens here is we've got 2 partners that try to escape. Only one of each of these make it out. So we just have x squared. This poor guy right here, he did not have a partner at all. So he's stuck on the inside. So whenever we simplify this, we have 2x squared times the square root of 15x. The reason that this works like this is because if we take the square root of x squared, we get x. So both of these are x squared, and we're taking the square root of them, which gives us x. So let's look at example 7. Example 7, we have a couple different variables here. We also have 180. So 180, again, is not a number I know a lot of the factors of. I'm going to start with higher numbers, so maybe like, I know that 81 will not go, maybe 64. That does not work. Maybe, let's see, 49 is not going to work. Maybe, let's see, 36. And that works. So I'm going to break this down to 36 times 5. And I've got x, x, y, y, y. So whenever I am simplifying this, the square root of 36 is 6. I cannot take the square root of 5. It is not a perfect square, so it is stuck on the inside. Here I have two x's. They're going to try to escape, but as they try to escape, only one of them makes it out. So I have an x here. I have two y's right here. They're going to try to make it out. Only one of them actually makes it out. The other one is shot. And then this poor guy right here, he does not have a partner, so he cannot escape. He stays on the inside. Now notice these x's and y's were separate. I sometimes tell my kids these are different prison gangs here. They will not help each other get out of prison. So if I had an extra x, it could not help that extra y get out of prison. You have to stick with just the variables that match there. So square root of 180, x squared y to the third equals 6xy square root of 5y. Let's do a couple more examples to make sure that we've got the hang of things with the variables. So here we have the square root of 75x, y to the third, v to the 8th. So I know 75 will break down into 25 times 3. I have 1x, I have 3 y's, and I have 1, 2, 3, 4, 5, 6, 7, 8 z's there. So the square root of 25 is 5. I cannot take the square root of the 3, so it stays on the inside. This x does not have a partner. It does not matter that this extra y over here might could help him. They're in different gangs, so they will not help each other out. So this x is stuck. For the y's, I only have one pair that's going to try to make it out. So I will have one y on the outside. This extra y will be left on the inside. And the z's, I have 1, 2, 3, 4 pair that try to make it out. So I have z to the 4th on the outside of the square root. There are no z's left inside of the square root there. So this is how we would simplify this radical. Now you might be starting to notice that maybe you could use a shortcut here, because writing all those out is kind of difficult. So if you have an odd variable, you'll have a leftover. You must keep that in mind. Even variables, you're just going to divide the exponent by 2 because they are in groups of 2 here. Let's look at example 9. Example 9, I've got 2x times 112 x to the third, y to the 4th. And whenever we are doing this problem, we want to break down 112, not a number that I know a lot of multiplication tables with. So 112, if we try maybe 16, that works. 16 and 7 will work. So this 2x just stays out front. We don't really mess with it right now. So we have 16 times 7, and then we've got 3 x's, and then 4 y's. So as we do this problem, that 2x is just going to stay out front, and then it will be multiplied by whatever we pull out there with it. So the square root of 16 is 4. 7 we cannot take the square root of, so it stays on the inside of the square root. I've got these two x's are going to try to get out. So I'll have one x that makes it out. This one right here stays on the inside. Then I've got 2 pair of y's that try to make it out. But we know if they try to make it out, only one of them is going to make it. So we'll get y squared here. Now we can combine this stuff that we have here. So 2 times 4 is 8. We'll have x squared, y squared, times the square root of 7.